AI security. The Agentic Attacker Arrives. The industry has been warning about autonomous AI-driven offensive tooling for over a year. This week, Hugging Face disclosed that the warning materialized, and it looked nothing like the drills. An autonomous agent framework, likely built on an agentic security research harness, the specific LLM, remains unidentified, breached Hugging Face's production infrastructure through two code execution paths in the platform's dataset processing pipeline. From there, the agent escalated to node-level access, harvested cloud and cluster credentials, and moved laterally across internal clusters over a weekend, executing more than 17,000 individual actions across a swarm of short-lived sandboxes with self-migrating command and control staged on public services. The most operationally significant detail in the disclosure is the guardrail asymmetry problem. When Hugging Face's incident response team attempted to use frontier models behind commercial APIs to analyze the attack logs, real exploit payloads, C2 artifacts, credential references, the provider's safety guardrails blocked the requests, unable to distinguish an incident responder from an attacker. The team pivoted to GLM 5.2, an open-weight model running on their own infrastructure, which had the secondary benefit of keeping attacker data and compromised credentials from leaving the environment. The practical lesson Hugging Face draws explicitly: have a capable model you can run on your own infrastructure vetted and ready before an incident. The attacker was bound by no usage policy. The defenders were blocked by their own tools. That asymmetry is now a documented operational failure mode, not a theoretical concern. The same week, a hacker wiped Romania's entire land registry database after a failed extortion attempt, bringing the country's real estate market to a standstill. The National Agency for Cadastre and Real Estate Advertising has been offline for a week. Notaries cannot record transactions. Citizens cannot obtain proof of ownership. The attacker entered with valid credentials, mapped internal systems, and deleted both live data and backups. An offline copy appears to have survived, but Romania joins Greece, Montenegro, Thailand, Sri Lanka, Bermuda, and Antigua as countries whose land registries have been compromised in the past 3 years. The hacker, operating under the handle Byteo breach, was subsequently doxxed as an individual from Oran, Algeria. On the defensive side, Capital One open-sourced VulnHunter, an agentic AI security tool that reasons like an adversary rather than scanning for patterns. Built on Claude Opus running inside Claude Code, VulnHunter flips the conventional SAST model, instead of searching backward from dangerous sinks. It starts at attacker-accessible entry points, APIs, file uploads, network messages, and reasons forward to evaluate whether an attacker can actually break through. After identifying a potential vulnerability, a falsification engine runs a structured workflow designed to disprove its own findings, searching for flawed assumptions, logic gaps, or security controls that would block the attack. What survives gets an executable exploit path and a proposed fix. The 3-skill loop, /vulnhunt to find, /vulnhunter fix to remediate with TDD, /vulnhunt fix verify to independently validate, is designed to run unattended at scale across multiple repositories. ClaudeBrain takes a complementary approach, a 500-page offensive security wiki indexed for semantic search, wired into Claude Code via MCP and deterministic hooks. Hunt skills fire per vulnerability class: XSS, CQuili, SSRF, IDOR, Cloud misconfigs, Active Directory, each querying the wiki before attacking and emitting uniform findings. The state-first engagement model ensures nothing in scope gets skipped and no dead end gets retried. The kind of operational discipline that separates a structured assessment from an AI throwing payloads at a wall. The through line is unmistakable. Cybersecurity teams are asking sharper questions about AI reliability than most AI companies ask about themselves. As one practitioner building customer-facing AI agents for security firms noted, these teams immediately start thinking about everything that can go wrong. Reliability, hallucinations, policy violations, behavioral drift, because they already operate in domains where failure has consequences. Open-weight arms race and AI geopolitics. Xi Jinping spoke at the World AI Conference this week and reaffirmed China's commitment to open-source AI as a vehicle for openness and win-win. The statement lands at a time when multiple signals pointed in the opposite direction. Earlier reports suggested Beijing was exploring restrictions on overseas access to China's most advanced models, with the Ministry of Commerce holding meetings with Alibaba and ByteDance about potential limits. Xi's public posture resolves that ambiguity, at least rhetorically, toward openness. The community reaction reads the move as strategic. Chinese AI labs are training frontier models at a fraction of US costs. And coupling that with a policy pushing models to be trained and served on Chinese-made chips creates a potential path to selling all the shovels in this AI rush. Compute hardware, power infrastructure, and the models to run on them, to any country without export restrictions. Case in point, Moonshot AI unveiled Kimi K3, an open-weight model the company claims rivals frontier offerings from Anthropic and OpenAI on agentic and visual benchmarks. The community response is appropriately divided between excitement and skepticism. At an estimated 3 trillion parameters, K3's practical reach is limited. Q8 quantization would demand hardware well beyond any hobbyist setup, and the model has only been available for hours on a first-party provider that few people actually use. The benchmarks are promising, but the community rightly notes that real-world performance on sustained coding or complex reasoning tasks rarely matches chart-topping scores. The trend is clear, though. The gap between open and closed models is no longer measured in years or even months. At the other end of the scale spectrum, Apple is reportedly in talks with PrismML, a Caltech spin-off that claims to compress models like Qwen27b down to ternary quantization 1.58-bit, small enough to fit on an iPhone. The discussions are characterized as very early, and the CEO's own description. Things are progressing nicely, is the kind of phrasing that could describe anything from a signed partnership to a polite email reply. The compression technique itself faces legitimate scrutiny. Nobody in the community has demonstrated that ternary quantization at this ratio preserves the capabilities that make models useful beyond benchmarks, particularly long context reasoning and coherent multi-turn interaction. Model routing and token economics. IBM Research published a refreshingly honest account of why model routing is harder than it looks. The core finding: across 417 tasks on the App World Test Challenge, Claude Sonnet 4.6 cost $79, total $0. 19 tasks, while GPT 4.1 cost $155, $0. 37 tasks. Nearly double, despite GPT 4.1 having lower token pricing on both input and output. The explanation is caching, which most routing discussions ignore. Agent workloads reuse large chunks of context across steps, and Sonnet's lower cache read pricing meant it benefited disproportionately from this pattern, enough to overcome both its higher base pricing and its longer reasoning trajectories. The team's broader lesson: routing is not a classification problem which model is best for this task, but a systems optimization problem across cost, quality, and latency simultaneously. Their lightweight optimizer 6ms, 2 KB memory per decision traced out a cost accuracy frontier. One configuration delivered 84% accuracy at $93 with a 21% cost reduction versus running Opus alone. A standard difficulty-based router landed at similar accuracy but higher cost. OmniRoute is one practical answer to this problem at scale. The open-source gateway connects 250 AI providers, 90 plus with free tiers, through a single endpoint, with 18 routing strategies ranging from simple priority lists to cost-optimized selection, context relay, and a fusion strategy that fans out to a panel of models and synthesizes via a judge. Its compression pipeline stacks 10 composable engines: RTK tool result filtering, Caveman prose compression, LML lingua 2 ML pruning to save 15. 95% of tokens transparently. The architecture includes circuit breakers, connection cooldowns, and per-model lockouts. 3 independent resilience layers that keep requests flowing when individual providers fail. It ships as NPM, Docker, desktop Electron, or even on Android via Termux. A Quesma engineer learned the token economics lesson the hard way. The first run of a deep research pipeline burned through an entire Claude Max 5x subscription limit in 30 minutes. 111 agents launched, 123 claims queued, 25 verified, 0 final output. The fix was architectural. Use Claude Code as the main harness, Codex and anti-gravity as headless subagents via a bash wrapper, all sharing memory through a locally extended plugin. Model routing by role. Sonnet for search, Opus for verification, Fable only for planning and dispute resolution. Extended continuous research time from 30 minutes to hours without additional spend. The most practical insight, context compaction, can double your bill instead of saving it when the summarization call consumes tokens and evicts files the agent still needs, triggering a reread recompact loop that inflated one practitioner's usage from 89 million to 185 million tokens on identical tasks. Underneath the routing layer, the wire format matters. GCF GPU compute format is a Rust-implemented alternative to JSON that claims 92% smaller payloads with 100% comprehension across every frontier model, 0 training required. The key differentiator over prior contenders like Tune is multi-turn session deduplication and delta encoding. By the 5th overlapping call in a session, GCF delivers 99% fewer tokens than resending JSON each turn. Adoption already includes Chrome DevTools MCP47K stars, Speakeasy, and OmniRoute itself. Agentic coding tools. and developer workflows. Command Code raised a $5 million seed for what it calls the first frontier coding agent that continuously learns your coding taste. The pitch. Every accept, reject, and edit is a signal that auto-generates into project-level skills. No rules to write, no prompts to maintain. The Taste One system uses continuous reinforcement learning to distill developer preferences, and the results are shareable across teams via NPX taste push/pull. The tool ships with interactive CLI, headless P mode, and background sandbox, supporting open models from DeepSeek, Minimax, Kimi, GLM, and others with $10. 40 in free credits. Tom Preston Werner, GitHub's co-founder, offered the endorsement. If I were building GitHub for software built with AI, Command is what it would look like. Kimchi takes a different angle on the same problem. Rather than learning taste implicitly, it orchestrates models explicitly. A task classifier routes each request to the best model for the job, with a high-reasoning model scoring output against original intent after each milestone. The Spend console provides coding-specific cost breakdowns by user, tag, and API key. The kind of financial visibility that enterprise teams actually need. Migration from Claude Code is one prompt. Kimchi detects existing installations and offers to import MCP servers and skills. Castor addresses a layer neither touches. The declarative specification of agents themselves. Written in HCL, the same language as Terraform, a Castor module defines agents, tools, prompts, models, and targets as a versionable, reviewable contract. Castor validate checks references. Castor build compiles to runnable LangGraph projects. And Castor plan Castor apply reconciles hosted agents with Terraform-style diffs and drift detection. The philosophy is that agents need a source of truth before they become serious software. The generated code is an output, not the contract. It is early proof of concept. LangGraph is the only codegen target, but the bet that agent specifications should be reviewable and diffable mirrors what happened to infrastructure a decade ago. From second brain to production agent, Cole Madine's analysis of why the Karpathy LLM wiki pattern does not scale beyond personal use cuts to a structural limitation. For a personal agent, Claude Code, Hermes, or any coding SDK managing an Obsidian vault, Markdown is ideal, simple, flexible, no governance overhead. But as soon as other users interact with the agent, the model breaks. Markdown cannot handle concurrent access. Organization degrades as the knowledge base grows, and the subscription-based coding SDKs are both too expensive and too slow for production traffic. The architecture that replaces it has two components: a context retriever structured MCP access to business data with auto-generated filter and search tools and agent memory short-term conversation state, automatically promoted to long-term vector index memories by a background extraction process. In Madine's Redis Iris demonstration, a single MCP tool call replaces what would have been reading an index document, navigating to subdocuments, and parsing unstructured text. The query for delayed orders returns in one call regardless of database size. The incident to evolve synthesis pattern from the AI pattern book addresses the other production gap, ensuring agents do not regress. The discipline is straightforward but hard to maintain. Every production incident becomes a two-part fix: repair the underlying pattern, then encode the failure as a permanent eval that reproduces it. The eval lands in the same commit as the fix. The CI gate runs it on every relevant change, and recurrence becomes structurally hard rather than routinely surprising. A support agent that invented a non-existent refund policy. A coding agent that deleted a migration file it judged unused. Each becomes a golden test case that no upfront test designer would have thought to write. The maturity signal is the ratio of incident-derived evals to hand-designed ones. A young suite is mostly imagination. A mature suite has absorbed enough production reality to carry incident numbers on a growing share of its cases. Local AI, hardware hacks, and creative frontiers. The CMP170HX is a cryptocurrency mining GPU that NVIDIA shipped with its memory artificially capped at 8 GB. A patched set of open kernel modules for driver 610.43. 03 unlocks the full 64 GB of HBM2E and 173 TFLOPS of BF16 compute. The installer builds from source, blacklists Nouveau, rebuilds Initrumps, and requires a cold reboot. The catch is PCIe. The card is physically wired as X4, missing AC coupling capacitors on lanes 4, 15, and the current unlock only reaches Gen 2. About 2 GB/s of bandwidth. That wrecks multi-GPU inference and limits host device transfer speed. But for single-card image generation or batch local inference where the model fits entirely in HBM, 64 GB at this price point is extraordinary. Some community members report renting unlocked CMPs for half the cost of a 100S. The GGML runtime continues expanding beyond text. Trellis.cpp, a GGML port of Trellis.2, now produces 3D assets on par with the reference implementation after a significant debugging effort. This means top-tier open-source image-to-3D generation runs on any GPU with enough memory, or even on CPU for the patient, without requiring CUDA. The project connects to Lemonade for an integrated experience with optional text to 3D cascading. Topology remains useful for rough drafts that need retopologizing for rigging, but the output quality in the screenshots is a visible step change from earlier ports. The full creative pipeline is converging on local hardware. One developer produced a 4-minute animated film overnight on an M5 Max MacBook One, 8 GB Wi-Fi off. Flux draws the stills, WAN 2.2 and LTX animate them. Piper narrates, Ace Step writes and performs the score, and FMPEG stitches everything into a finished film with titles and credits. Characters drift between shots, motion comes in short clips, and longer films take about 12 hours of compute. But it is a complete movie from one pipeline on one laptop, an outcome that would have been unthinkable a year ago. The pipeline is open source. Ghost in the Droid gives AI agents a physical phone as a tool surface via Model Context Protocol. The agent observes a screenshot plus a compacted accessibility tree and acts through 62 tools. Tap, swipe, type, launch, batch flows. Over ADB with no app on the phone and no root required. iPhone support arrived this release via WebDriver Agent. Because Ghost is just the body, any model, cloud or local, can serve as the brain. Meanwhile, Grok's video generation is drawing reactions like this doesn't even look AI generated anymore. The community is more measured. Eyes that do not blink, mouths that open too wide, the uncanny valley artifacts that read a 70s TV show to a critical viewer. But the trajectory is undeniable. The gap between AI-generated video and conventional production narrows with every release, even if the last mile of realism remains stubborn.